Monsieur. Comment allez-vous? No, so obviously I'm not Florence Dubois. So Florence is actually on my team. She's out of the UK. We're on the DB2 SWAT team for ZOS, so led by John Campbell. But she didn't make the trip, so she punted, and I fumble recovered. So you guys have me for this. So my teammate here, Saghi, Amirsoleymani, she likes to bring me around because I don't know if I can pronounce her last name at the lab. But also known as Optum Saghi or Queen of Optum. So she's part of our enablement team, sales, development, everything. So let her talk about herself. But we've got this topic, taming the dynamic SQL beast. So we're going to do the outline for this is I'm going to run through the overview, what global statement caching is, local statement caching, performance, odds and ends, suggestions, and then Saghi's going to take it over and tell you how you don't even care about all the rest of the stuff. It can be done easier with tooling, either free or for fee. So that's kind of how this is going to roll. If you guys were here earlier in the week, I may refer back to Rita's presentation from Shelter because it was an excellent deep dive into how to analyze and dig through the data. This is going to be a little bit higher level, what's in there to look at in the first place. So dynamic statement caching. So who all here has dynamic SQL running in their environment now? Okay, nobody's here just for the gee whiz stuff, right? Okay. So obviously with mobile and DRDA and all the other stuff coming in distributed, it's a lot more popular these days. So dynamic statement caching, the overview is, first one, no caching. So what are we talking about here? What actually goes on? So you've got a program that comes in, some dynamic SQL, does a prepare. The prepare is, hey, DB2, I'm about to send this SQL in. So we go through and pull out, create the runtime structures. We look at authorizations, where the tables, columns exist, and so on. If you're authorized to look at it, we build a runtime structure, and then he requests to execute the SQL. Then we execute the SQL, give it back to him. Then he commits, goes away. Program B comes in. Once again, it's a full prepare. So that means we have to go through, do access path, find the objects, authorizations, so on. You execute. When you commit, this statement goes away. That thread goes away. The statement goes away. If you come back in, he tries to execute again without a prepare, without asking permission, so to speak, you'll get some negative SQL codes, right? Either you don't have a cursor or your statement isn't prepared yet. So then, to execute successfully, he has to re-prepare. We've got the statement here, comes back in the thread, back in thread storage, executes, and we're good to go. So that's the long, overpriced way, right? So this is why we have caching. Significant cost to fully prepare a statement cache. So the Nitnoy numbers, because somebody's going to ask, is roughly 2,500 microseconds for a full, 75 for a partial, or, well, if it's already in the cache, and then 25 for local. Right? So it's basically, if you're looking at dollars and cents, it costs $1 to prepare it. It's 3 cents if it's a short prepare, meaning you're using global caching. And it's about a penny if you avoid all prepare, so you have local. So that's kind of how it runs down. If you're looking in the accounting traces and stuff, prepare can be up to 50% cost of the entire thread running. So I don't know. The base story is you want to have it on. So it came out back in version 5 for either static or dynamic statements. I came in just before version 9, so if you have any other questions, you can ask Saghi about the other stuff. But back in version 5, it was sort of not so useful for us, right? Because until version 8, when we went to 64-bit for DBM1, nobody had enough real or virtual storage actually to do anything with it. So it was out there teasing you couldn't do it. What do we cache? Basically any DML, right? Select, update, insert, merge, so on. Quite a few limitations, so the statement has to be identical, right? So this is a big thing about literals. We're not going to go into it in here, but version 10 brought out the consolidate with literals option. So that's a way, if you have applications that refuse to use parameter markers, it's all literals, there's a way to condense those down. Like I said, we're not really going to get into that now, but it has to be, the statement has to be identical, including any trailing blanks or anything else after it. So it's very specific of whether or not you get it. And then, of course, authorizations. So has to be the same auth ID. If you're using RACF and secondary auths, that's fine as long as the secondary auths match and or you're a superset of the auth, should be in good shape. Bind parameters, special registers, you can send across things for parallelism and stuff, and how many degrees of parallel you want to go. All these little things have to be identical for you to get this cache hit. Reopt. So who in here uses a form of reopt as specified? A couple folks? Okay. So there's always, which means don't cache, right? So you're kind of avoiding it. Then you've got once and vars or auto. Once is used by some of our ERP folks like SAP, so that's a big one. So reop once says, when you first issue this SQL statement, I'm going to take the literal value that you have, even if you've got a parameter marker, I'm going to take the real value behind it, and I'm going to do the choose my access path, right? Do the access path optimization based on that real number. So if you have huge data skews, you can get into trouble with that because we're going to choose the access path based on one specific number, and then everybody else is going to follow that access path. And then, of course, things that go to the accelerator are kind of a moot point here, so we're not going to go into that. And global versus local. So let's get into that. So for global dynamic statement cache, I showed you the picture before. I'm going to come in, prepare, right? We'll build all the runtime structures, get a copy out here. If you have caching on, we're going to put this skeleton dynamic statement out there, right? Just like you have skeleton cursor and package tables for the other EDM pools. We've got skeleton in there. You're going to prepare it. We'll put our little our skeleton out here, execute on it multiple times. The good part here is program B comes in, like we saw the first time. He uses a prepare, and we find out we've got a hit in the cache here. So he copies the skeleton down into his thread storage, right? So this stuff is all in 64-bit shared storage. He copies it down in his own thread storage, and we have a short prepare. So that's the big hit for your money, so to speak, right? Goes from $1 down to roughly 3 cents. And we execute, do great. When we commit, we delete the skeleton in my thread storage. The skeleton is still out here, right, in the global statement cache. But when I commit, my thread and my version of it goes away. So once again, if I come in and try to do execute without a prepare request, I'll still get that negative SQL code. But when I do the next prepare, then I pull that copy out of the cache and run with it in my own storage. So I said this, this one skeleton can provide the skeleton input for hundreds or thousands of threads. There's no limit on how many it takes. So that's cache dynamic. Enabled by zparm, cache dynamic, yes. Easy enough, right? The EDM statement cache, zparm, what was it, 1 gig up until version 10, and we upped it to 4 gig max size in version 11. Obviously, like I said, the executable runs called the SKDS is going to live there for the duration until it's either pulled out by LRU mechanism because you've hit their EDM statement cache size, or something like bouncing DB2, some other stuff. We'll talk about when it's invalidated. But the key here is the prepared statement isn't kept across the commit in the thread storage. I want to make sure we differentiate between, if we're talking thread storage, we're usually talking about local statement cache. And here, that the SKDS is still in the global cache, but the thread storage, everything else goes away at commit. So how do we invalidate it? Alter, drop, revoke, create index. These are sort of obvious. Reorg and load, obviously, because we're going to go through and rebuild some indexes. Run stats is the one. Less customers are worried about accidentally invalidating cache and more worried about how do I force things out. For instance, I've got a poor performing access path. I want to get that thing out of the statement cache, and hopefully DB2 will make a better choice the next time around. Or I'm going to update my stats on purpose so I can encourage a different access path. So the trick here, right, is a run stats update none, report no. So we're not actually changing things in the catalog, but we can flush the statement out. Anything related to those objects you run the run stat on. If you do a real run stats, a normal one, we're going to update the stats and also invalidate it. So it depends on if you're trying to change the statistics in the table to give the optimizer some different ideas about what access path it should take, or you're just trying to wipe that stuff out of the cache. As I mentioned, they get removed when there's no more statements in there, and then we go on an LRU. So whoever hasn't been used in a while, we'll kick him out and use somebody else. The key here, one of the big things difference between global and local, right, is global, I set a size for my skeletons. It's just the number of those SKDSs we're going to fit in there, which is, like I said, up to 1 gig to version 10. And the local is going to be based on the number of statements. So that's kind of the key here. You don't really know how many you're getting, it's just the size of it. So local dynamic statement cache. You can do local by itself, but it's kind of a moot point. And I hope you see that in our little picture here. But if I have global dynamic statement cache with cache dynamic yes, and I've got local because I've bound and packaged with keep dynamic, then I get the biggest benefit, so to speak. We'll talk about the limitations in a second. So I'm going to come in here, my program A, I've got nothing in either cache. Comes in, prepares our statement. I get my skeleton out here in the global. He executes. La-di-da goes along about his way. Then program B comes in. He gets a short prepare, so he gets a hit in the global cache, pulls that down, starts running in his environment. And because we did global and local for this guy, not only does he get a short prepare because the thing was already in the global cache, we get this first short prepare when he comes in, executes. He does a commit, and magically, here's our local statement cache. After the commit, his statement, his local copy that he has, right, the internal version of it in his thread storage stays. So that the next time he executes, I get prepare avoidance, right? So he got the global hit the first time, got a short prepare. The next time he executes after the commit, he doesn't do any kind of prepare. And this thing can run on for quite a while, right? A lot of the SAP applications, you'll see the same statements in here for weeks on end. Any questions on that? It's not too complex, and there's not even any animation, so it can't be that complicated, right? So local dynamic statement enabled with a bind option, keep dynamic. This is not something you go across the board, right? You're not going to go rebind all your JCC, sysl, H, whatever packages with keep dynamic, because you're going to persist threads forever and run out of, if not virtual, then some real storage. The key here is it's kept across the permit, but the application logic has to understand that. So if you go in on the previous slide, if program B comes in and says prepare, he gets a global statement hit, execute, commit, and then he requests prepare again, he'll go back and get another global hit, but he's not going to use the one in the thread cache, right? So if you ask for prepare, you're going to get, at least in this case, a short prepare. So the application has to know not to ask for a prepare. That's why not a lot of folks, or at least not everybody, right, is running with local dynamic statement cache. SAP has its own internal cache mechanism. He knows when he's asked for prepare, and then other things like WebSphere and some of the options in the driver are getting smarter. But WebSphere, for instance, has its own cache on the application server side to know when we did a request for it. So there's a little bit more work involved. Otherwise, you're just going to end up with a flood of useless statements that we can't really reuse. It can be stored in several threads. Like I said, it's the same copy of the statement, but running in that local thread cache that's in 64-bit shared, starting in version 10. Max keep D is the number of dynamic statements, right? So it's not a size. So if you have some SAP BWBI queries coming in that are like 2 megs or whatever, you're going to keep however many number you've specified in that size, right? So this is why we're cautious about using it prior to version 10. Because in version 10, we finally moved the whole local statement cache above the bar. So that was the key to be able to use it. And of course, the hit ratio in this, usually we see it very high because customers who've implemented it have the application coding to go behind it, or it's an ERP vendor app that was designed for the thing. But this is one that we see can get into trouble as far as the storage size. Of course, we've got some measurement numbers in the 1011 performance manual. So if you go from like SAP's piece, they went from 0 local statement cache to 64K, as far as 64,000 statements. And they got like a 75% improvement in elapsed time and 50% throughput. Well, that's great if you really are getting a local cache hit, right? But that's not guaranteed at all. OK, so what are the limits here? We'll lose it if the statement ID is reused. So it's an integer value. So if you roll past 2 billion, we'll get rid of it. Max keep D, this is your number, right? You specified in ZPARM. Rollback is one that we see that customers maybe weren't aware of. So if you've seen some applications, for some reason they seem to be all in Europe, but they'll enable the local statement cache and go through, and every couple of them will do some authorization check and are made to roll back. They're supposed to fail, right? It's kind of an exception processing. Well, if you do that, that throws the statements out of the cache. So we've seen horrible local statement cache hit numbers, right, in stats reports because of them doing rollbacks. And it was intentional, but they didn't understand what the impact was going to be on their local statement cache. Of course, if we deallocate the thread, right, because the storage is in the thread itself, when that goes away, we've lost it. This is on by default. This It used to be a hidden ZParm, now it's an opaque ZParm. I think a cache dynamic free local just says if I'm running out, if over 75% of my virtual storage is being filled up below the bar in DBM1, start throwing out big statements. So this is on by default. It's kind of your safety valve, so to speak, for local. So this is what we go and look at on a customer site. This is from our one-day workshop we do on statistics for the team. We're looking at dynamic versus statement, or local for the cache hits. So my global dynamic statement cache hit ratio, we've got in red up here, right, is going to be my short prepares divided by short and full. So we're aiming at short prepares. In our little example, got 125,000 requests, and then 108,000 of them, or 86%, were short. So that's what percentage of time I had a hit, right? That SKDS was in the global cache, and I saved, 80 cents on the dollar. Down here for the locals, implicit prepare means that I went to look in the local cache and it wasn't there, so I got it from the global and then I prepared my own statement internally in the thread storage. Prepares avoided means I had a hit in the local statement cache, right? So there's our quick little statement down here, equation, prepares avoided over avoided implicit. So if you see implicit prepares, it can either be, you may have a global hit, which would be a short prepare, or you may not have it in the global, and you get a full prepare, right? So this implicit can either be really expensive or a little bit expensive. And you'll see that our prepared statement purged is a sum of two values, right? It's either purged because, we ran out of space, you hit max keep D, or we did run stats and validated for some other reason that the DBA would be in charge of. Any questions on hit ratio stuff? Anybody seen some odd numbers? Usually for the global, we're looking at 80 to 90% is what we'd want to see for an efficient cache hit. For local, between 80 and 100. Like I said, usually because it's application dependent and specific. If your local statement cache is less than 50 or 60%, it may not even be worth it as far as the storage you're giving up to get that CPU bump. So recommendations, always use global, period, turn it on, and then monitor, try to aim for that 90% global statement cache hit, and really the way you tune that is to make it bigger. Kind of like our buffer pool strategy until you get to 11, right? You get up to the knee of the curve where the bigger, you make it bigger and you don't get any more, bang for your buck, no more hits in the global statement, then you stop adding to it. Well, unless you hit the max limit. Local statement cache, very selective, right? Based on the application. You've got to bind it with keep dynamic, which if it runs, if it works, you can get the hit, great. But remember, keep dynamic kind of avoids some other stuff we have going on, like sysplex workload balancing, if you were in my other session. So if you've got keep dynamic, we can't break in, the driver can't, it can't balance the workload across the sysplex with keep dynamic, because we can't break in at a commit level because you're persisting, right, that statement across a commit. Also, if you want to break in with DDL and other things, that statement's still there. It's kind of like a release deallocate, but to the next level. And of course, you got the data source properties you can do. If you're going to do the packages, obviously, we want you to bind, like your JCC driver packages, into a separate collection and point that guy using the current package set special register. The applications that use keep dynamic, point them to a different collection. You don't want to enable this for everybody worldwide. And of course, like I said, DB210 opens the door for storage. There are some hits in the listserv I saw earlier this week, and I think Pat Bosman, who was here, also commented on it. But there's a customer who was getting negative 904s in the statement cache. You're like, well, that's kind of weird. Well, that's because we've run out of storage. And it didn't mean storage in the statement cache. There's 3 reasons for it. We've got an APAR coming out, hopefully in the next couple months, that'll tell you more specifically why you got a 904. But this guy was getting 904s, and he was bugging me, wiped the cache out, and the problem went away, and it built back up again. And he finally went to his system people and asked, and apparently they were using between 50 and 60% of their available aux storage. So at that point, DB2 kicks out a message or receives a message from ZOS and ENF55 and says, ooh, I'm short, forget caching. No, like we're trying to conserve it. I was like, dude, he said, oh, well, we went back to the system folks and we got it down to like 50. I'm like, dude, do you know what happens at 70% of aux At 70% of aux, if I can't displace you, I will make you non-dispatchable, and you will not go anywhere, right? And then at, well, just over 90%, sometimes the LPAR comes down. So do not overcommit your real storage, and you shouldn't be an aux anyway, but if you see some weird negative 904 things coming out of the dynamic statement cache, you could be in serious trouble on the system side. You know, not your fault. Go beat up your ZOS and capacity folks. Okay, so monitoring. Go through some of the basics on this. These are the 3 if kids were interested. These are the explain tables that are added for the dynamic statement cache. This DSN statement cache table is a key one. We'll talk about the rest. And obviously for explain, we put some extra explain support in version 10 to help with dynamic statements, because we've had it obviously for static for forever, bind with explain, yes, but we want to be able to give the same support for our application developers using it for dynamic. So the IFKID 318 is the key to everything here as far as the statistics you're going to get out of it. And as long as you have accounting class 3 on as well, we can see all the suspension timers, right? So this isn't a complete list of all the stats in here, but runtime stats, right, that are cumulative for that statement. So you'll see over time as it progresses, if you push this information out to the dynamic statement cache table, you can see things like how many times it executes, get pages, buffers, I/O, did it do a table space scan, the locks, suspenses, reasons for class 3 suspension. 2 of the interesting ones that we tend to look at for SQL efficiency would be rows examined versus processed. So if I end up with 3 rows, right, but I do a table space scan to get there, I'm going to have an enormous amount of rows that were examined, and my rows processed, which made it through the sort, for instance, might be very small. So the ratio of these 2 is kind of an interesting one to see how efficient the access path was. But there's a billion combinations you can go and look at it. The key here for 318 is starting and stopping it wipes out those stats. So I may keep going back and hitting up Rita's presentation from earlier in the week, but if you want to take a timeline or understand the context of the statements, right, you might want to start and stop that thing in an automated fashion so you can push those stats out and then understand what the next day looks like if you're going to compare back and forth. IFKID 316 and 17, these are more for if you're going to write it out, for instance, to SMF or a monitor, like a monitor 1 trace. 316 provides, as long as 318 is on, it'll push out the stats as well as you'll get a statement ID to uniquely identify it, and you'll get the first 60 bytes of the statement. I said you can use it for IFI reads, and it requires that you have the monitor 1 trace on, which I think Saghi may hit for Data Studio and some of the other tools that use it. And the good thing about this is if you do write it out to SMF, right, you can get the stats for the statements that have been purged from the table. Because depending on how volatile your dynamic statement cache table is, right, and how many dynamic statements you have coming through and how big it is, you may find something that was interesting or have some accounting records or stats and then go back and try to find the statement and the thing's already gone, right? Or somebody did a run stats or whatever else and purged it and you lost this guy. So going back to write it out to SMF, GTF, or an OP buffer, you can go back and look at retroactively what happened. So that's why you'd have that on. And 317 is to get you the full statement text. Yes, sir?
With the externalization, if you enter the 318 off, you delete the Florence information. Does it externalize the stuff in the cache like pipe via this mechanism, or do you just lose it?
No, when you turn it on.
If you turn down, then obviously the cache just loses it, externalize the data, or do you just lose it?
You just lose it. So it's not.
You don't get a complete list of the things that are gone.
Correct. Yeah, so the point was if we bounce DB2 or DB2 crashes or anything else in the middle, we're not going to externalize it. You have to tell us to externalize. So what you want to do is explain statement cache all, which we'll get to in just a second. That way you know you've flushed that to your statement cache table and it's hardened, right, for resiliency and to look back at it. Otherwise, just poof, they're gone. So explain statement cache all, as I mentioned, populates it. So that's how we call it snapping the cache, right? Explain statement cache all, everything that's in there in memory, run stats, or the statistics for the statements that are running right now, push it out to the table, harden it, and go back, post-process, unload, wherever you want to do for it. It's a row per cache statement, and you need one of these two authorities to get it. Sysadmin, getting a little questionable these days. I've been on calls where level 2 is, or they said, well, look, I snapped the statement cache, and all I got was the stuff with my auth ID. That's not very useful. Oh, well, you just need sysadmin. Oh, I just need sysadmin. Super. Let me run over and do that real quick. I'll grant it to myself. So SQL Atom in version 10. So with the new authorities and privileges, you can do SQL Atom. There's also, you can grant the authority for explain at a subsystem wide that can help with this. Also does the execution stats, right? This is, like I said, we push it out for it. As long as 318 is on, we can get it all out. You don't need 16 and 17 to populate this table. The table has all the stats in it, and it's also got a lob column and an auxiliary table space for the full statement text, because we won't fit all of it in line. And it's member specific. So if you have a data sharing group and you're trying to get the full picture of the biggest, ugliest ones or whatever, you're going to have to hit it on each member. The thing here, though, is unlike, when you say explain blah, 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 you think, oh, I'm going to get my actual access path and that stuff. No, not true here. 2 steps. 1, explain statement cache all kicks it out to the statement cache table, right, with all my runtime stats. But if I want to get the actual explain, the access path, the plan table populated, 1 more step. So let's talk about that. There's 2 options I can do with it, statement ID or the statement token. About the same thing. The statement ID is unique to that statement, and it's given to you by DB2 at prepare time. The token is something that you or the application are going to inject into it, so you can uniquely identify whatever it is you're doing. So the statement ID, it's an integer constant or host variable that we populate. Assign a prepare time. You can pull it out of the IFI monitors. And the good thing is this ID is pervasive. I think Bart Siegmund's had a good presentation the other day that talked about deadlocking and timeouts and all that good stuff, concurrency. So even if it's a dynamic thread, coming in, our favorite correlation ID, DB2 JCC, means I have no idea what's going on. There's my statement ID, statement identifier. So that's where I can go back, match him up in the statement cache table, see what his runtime stats are, and explain him and get the actual access path. So it's recorded through these other if kids, deadlock, timeout, so on, and the messages. So the good thing, it's all over the place. We should be able to track it down, as well as accounting records and so on. And if you do explain statement cache, statement ID, as well as the stuff we've already got in the statement cache table with stats, then I finally get plan table and these guys populated. So now I can go through and do some access path analysis or kick it into a tool if I want. Statement token, exact same thing, right? Except it's a token and something that you've done yourself. Yes, ma'am. So the question is, if I do the explain on the statement or the token, you always beat me to the punch. If you explain the statement, the ID or the token, am I getting the real access path, or am I getting what it would do now if I just did this out of the blue? So for the statement ID, it's doing that access path. The original. Correct, sorry, let me get this straight. So you're doing the one that it came as. When it was prepared, the access path it shows. The problem with a lot of this stuff is if it misses out of the cache, right, I grab that statement and I copy it and paste it and put it into a tool and say explain, and then what I get? What the optimizer just figured out just now while I'm looking at it, which is probably a great access path, right? It's not the table space scan or the nested loop that I got 3 hours ago when this thing started running. So that's really the key here, is when you doing that explain, right, is to pull it at that time and get that unique ID. It's especially painful in the SAP environment, right, where everything's a parameter marker and re-opt once. So 2 months ago, that thing hit the cache, right, and explained it got a great access path, index only. And then, the next time it bounced or something came up, that next explain or the next access path decision the optimizer made was a little poor, and we did some nested loop join. So now we grab it out of the cache and go, oh, well, I'll just explain the statement. Well, too bad. You got what shows up in the explain table is an awesome access path, but why is the thing running for 3 hours? So then you've got to go back to do the statement ID and that stuff, if you can find it. Yes, sir?
So when you're explaining by the ID, presumably it still needs to be in case to the actual access path.
Correct. Yeah, sorry. So the comment was the statement ID or token has to be in the cache resident for that to work. Exactly. That's the problem with customers who don't have the statement cache table and all this stuff set up, is that when we do that, it doesn't have a statement ID, or we don't know what it is, and you're just guessing. So when you have this horrible access path regression, like a large oil and gas company who held me hostage for 2 weeks does, you really want to have this set up already. Because if you're already, you go to a version-to-version release migration, just like we talked about explain tables. If you don't know what it looked like before, but you got a feeling it's crappy now, we'll help out however we can, but it's going to be a little more painful. So create the statement cache table, create those 3 explain tables, function statement plan, which, by the way, we've given you in the sample, the STMTCACHE job. So that's the DDL and everything for all these tables is in there. And before you ask, these 3 tables are in the same table space and they're segmented. So no, we're not exactly drinking our own Kool-Aid yet for that. But it's coming. We actually put an APAR out for 11 to make these PBGs. So then you're going to make sure these tables are available, start the collection, make sure the if kit is on, use the explain statement cache all, poof, it goes in the table. But then, as we mentioned, that doesn't populate the explain tables. So now I've got the stats, the runtime stats in there, but I need the actual explain information. So you're going to have to do, we've got a little, easy to do SQL there. There's also documentation out on the interweb. You could use that same statement, I'm going to select the statement ID and explain it here in one step. I probably don't want to do the whole statement cache. You may, but it's a lot easier if you're in your SQL, right? You rack and stack them based on execution or elapsed time, either cumulative or per execution. Pull out your top 10 and then have those explained right away, right? And that's actually what level 2 is going to do. Because usually, unfortunately, when a customer says, I've got problems in these access paths, when they're dynamic, a lot of times they don't even know. So level 2 will end up stacking them and saying, is this one? You go back one at a time, one off, it's a little painful. And then import this into a spreadsheet. Well, Saghi will show you how you can do that with a button, basically, in Data Studio. Or you can try to pull it down through maybe ODBC and stick it in your own Excel, or unload it in DB2 and pull it down multiple ways. So talking about all that, what about our poor developers, right, who really want to make sure their application is running well and efficiently and do all their due diligence? Because there's millions of them that are really interested in doing this. But anyway, so we've got the same explain, like a special register, which tries to, sort of extend the functionality that we had with static packages for explain. So this special register, we've got the ability for the application folks who may or may not have the authorization to execute the SQL against those tables to actually get their runtime stats as well as the explain information, right? Otherwise, prior to that, you'd have to make sure they put a token in, and they'd actually be cramming this stuff into your dynamic statement cache table, populating it with a whole bunch of stuff that nobody else cares about, right, for their individual application test. So answer current explain mode special register, and it's supported for JDBC and ODBC CLI. So what are the options? There's 3. No is default. It's what's going on today, right? Which means if you run the dynamic statement, it'll hit the cache, stay in there, get your response back, get your SQL result set. Current explain mode yes means run the statement and give me the runtime stats for it and the explain information, but it won't stay in the global statement cache, right? So we're getting the runtime stats for it and all the explain information, but it's not going to be in the cache, which means if you run it again, it's going to get re-prepared and you'll get the stats again. Current explain mode explain means you don't get to execute the SQL, but we'll give you the runtime stats and the explain, right? So if your application is dependent on getting the result set back to continue your unit test, that's not a good idea, right? Because it's not going to actually run your SQL. But this would be good if the guys don't have access to those tables. So requirement, you have to have a dynamic statement cache. Oh, okay. You've got to have the 3 tables that are out there as well, the explain tables. You don't have to have the 318 trace on for this. So once again, great for development environment. I don't want the trace on. There's single-digit percentage of overhead for that, and I'm not trying to populate my cache with a bunch of trash, because it's never going to be reused by an application, right? So I don't need the trace on. And with that special register set, they still get the actual runtime stats, including class 3 suspense and wait times if the accounting records are on. And I get all my information as a tester, right, a developer, to see what this thing's going to do. Hopefully, looks like what it would do in production. And I said it also works with the explain authority that we have starting in version 10. So turn it on and off quickly. I said, here's your examples of what it looks like in the connection property for Java or ODBC. Check each driver level tends to change this, especially ODBC. They don't really like to play our games, as well as the CLI driver. They've got 4 options, and 2 of them are a no-op. So just go in and look. It's release dependent, but 0 is off, and one of these numbers in here means yes. So they don't have an explain like we have. They only have 2 of the options, but they're working on it. So warning, don't do this in production. Hopefully you're not doing a whole bunch of testing in production. Anyway, don't raise your hand. But for this one, if you do yes or explain, right, it's not going to go in the statement cache. So you're not going to help anybody at all. You're just going to burn CPU time for it. So should be used in test only. And summing it up, it's got a nice little reference table that Flo built. When you come in, if you're going to use explain statement cache versus the current explain mode register, right? These are the collection IDs you'll come in with, so you'll know kind of who was doing it or why. And these are the join, sort of the join predicates, right, for the columns that compare. So you got statement ID in the cache table, and in your plan table, right, where your access path is, I've got query number. So you're looking at cache timestamp versus bind timestamp in the plan, right? Because the plan still thinks everything is actually bound. The difference, though, for current explain mode, right, we call it explain instead of the cache, because it's not going to hit the cache, is it? Right? It's avoiding it. So that's what our little simplistic kind of model is for that. We did have a question, a great question from another SAP DBA at Share who chased me down, and they had a problem where it was a BWBI query that had run amok, right? And they went in, and because it's not only keep dynamic, but it's re-opt once, when you first come in, the literal value is used, right? So the literal value can use different statistics, different run stats than, for instance, a parameter marker. Is everybody aware of that, possibly? Okay. Probably like, well, how come I can't swap this access path in the optimizer? Well, because we don't care, right? So unfortunately, with parameter markers, we can't use like some of the call group functions, right? We don't care about all the skew in the data because a question mark doesn't help us, right, know where the data is. So because it was re-opt once, they had literals. So what you want to do, if you have a problem with re-opt once, is you get the actual literal values from the developer or somebody who knows what it might be, plug that in, and then run, for instance, Data Studio against it. You'll get the run stats advisor option, and it'll take into account the literal and give you every option for run stats you could use. Whereas if you just plug in the one with the parameter marker, right, you're going to get a very generic default of run stats, which probably isn't going to help you in prod. So understanding what your re-opt values are and what's actually being used by the optimizer for the run stats is a key ingredient there. So, okay, last words of wisdom, and now it's on to Saghi for a much more dynamic presentation with pictures. Don't force yourself.
Yeah, that's really great. Any questions for Adrian before? Okay. All right. So I am here to make your life easier. So the whole point about doing this, and I would just correct Adrian to say, I am only here to show you no charge stuff, okay? So as we say, we're not allowed to say free in IBM, but if we give anything away at no charge, please use it, because IBM barely ever gives anything away, so please do. So I am here to show you how to mine through the dynamic statement cache using Data Studio, which means everything Adrian just said in 45 minutes, you'll be able to do in 5. So as long as you know the concepts of what Adrian just said, you now can do it easier. So if you notice that Adrian discussed this, going through the sample of how to go through the process of doing it manually. And it was pretty tedious of going through all those steps. And who has that kind of time, right? Especially being a DBA in your environment, there's probably only 2 of you, right? And you're totally outnumbered by the developers. You don't have the bandwidth to go through all that lovely stuff that Adrian just showed you. So I'm going to show you how to do it now. So first step would still be to turn on the ifsid 318. The second step would be to create those explain tables. Now, if you don't want to create the explain tables yourself, all you have to do is when you download Data Studio, there's a little program file, and it provides you the JCL, and you can customize it. Now, if you don't even want to customize your JCL, you can go inside the GUI and actually go ahead and create those explain tables. Now, what I don't want you to do is, I do not want you to create individual explain tables for every single person in your shop. Why? Because if DB2, in its bright wisdom, decides to ever change the size of the explain tables, you will have to migrate every single person's explain tables. So have one set for your DBAs, have one set for your developers, and you're good to go. There will be no corruption. There'll be no problems. Don't worry about that. But please, only have one set, OK? So then once you've done that, you then generate the individual explain statements for even every single statement in the cache. You analyze and tune, and then you have the option to import the contents into a spreadsheet, as Adrian mentioned. So we'll go through those steps. So if you notice in this GUI tool, you notice that along the left-hand side, there's little tabs. That's called our workflow assistant. So now it's more intuitive how you can follow through the steps. The first tab gives you the status of the database you're on, version 9, version 10, new function mode. It tells you exactly where you are. Second tab is where you capture from. OK, so now that I'm in the capture tab, I would then click Dynamic Statement Cache. Once you've clicked the cache, then you would go into the next step. Would you then pick a filter? Why do you want to do a filter? Once again, I'm going back into your time management. You do not have time to look at everything under the sun, right? So you filter so you can focus your attention. I'm going to give you a little tip, a hidden tip inside Data Studio. Please do not use our predefined filters. All they do is just give you to organized. It doesn't necessarily give you any content that you really care about. So if you customize a filter, when you customize that filter, you can just regenerate it every morning if you wanted to and just use the same filter. You do not need to reinvent the wheel every single time. That's why we're giving you this stuff at no charge, so you don't do these tedious tasks over and over again, right? So then once I've done that, now say my customers hate to turn this ifsid on. I don't know what happened after version 6. People think that it's going to take up so much CPU. It's less than 1%. He said single digits. I'm going to vouch for less than 1% CPU overhead with 318. Especially if you guys are looking at IDAA, please have this ifsid on. It's going to make your life a lot easier. Now, let's say I don't want to turn it on all the time. You have the ability to press this little button right there and enable and disable as you want. So you can enable the trace, capture that information. As long as those statements are in the cache, it'll actually get all that information for you. Then you have the CPU time associated with each of the statements, and then you can focus your attention on the most important statements you want to focus on. So the filtering options, as I mentioned again, we have more filters than you know what to do with, right? So what I did was I gave you my favorite. So what I do is when I create this one, I say cache top. I've picked my top 100 statements. When I did my top 100 statements, as you can see, is there a little, there we go. Top 100 statements here. When I picked my top 100 statements, I decided that I want to do it by primary auth ID. So anything inside DSN TEP 4, you can set more than one filter if you want to, and then you focus your attention even more. And I do statement text like. If I was looking at IDAA queries, for example, I would do statement like select, because insert updates and deletes don't qualify to be an IDAA. Or I could do my most famous, which is the executions and get pages. I did anything executed over 10 times, give me those queries. And then this is pretty small in our environment, right? 500 get pages. So you could do 1,000 get pages, and then you focus your attention. It's been said, if you do this every morning, and you just capture that top 100 every morning for the year, and you just analyze and tune and get your highest CPU consumptions, by the end of the year, you guys will have saved yourself between 10 to 15% CPU overhead by just focusing your attention. Because in the end, all the needles in a haystack will come out, right? You're going to notice patterns. You're going to notice things that are different. You're going to see that you're going to find these things that you're doing with these queries that you can make a difference on. So when do you want to schedule the capture? Let's decide. Now, you can do it, and you have options of scheduling the capture immediately. Right now, I'm just going to capture it now. I can say I want to do a periodic sampling once every hour on the hour. There is a store procedure within Data Studio that you can turn on, which is called the admin scheduler, that can do these scheduling of tasks. Now, in our environments in DB2Z, we hate turning on store procedures, right? So I'm going to give you a little bypass. As long as your Data Studio is up and running, you guys can schedule the capture. So if you notice that there's a problematic time period at 7 p.m., bring your laptop home, make dinner. You all bring your laptops home anyway. Make dinner, have your Data Studio up and running, and capture at 7 p.m. So as long as your Data Studio is running, you can always schedule the capture. Now, honestly, I've asked this before. And people are like, OK, well, then when do I schedule this sampling? How much time do you have in a day? Are you guys really going to be able to look at on the hour, every hour for the next 15 days? No. Anything is better than nothing. So you figure out, look at your monitor. If you don't have a monitor, kind of look at the time frames, kind of know your problematic time period. And let's say I run payroll every Tuesday, and that's going to be my highest peak time, all Tuesdays. So what do? Once a week on Tuesday, between 2 and 3, I schedule my capture. I do this the highest CPU consumption ones, highest executions, and I pull those in. Then I don't need to mine through the data and figure everything out. And maybe if I don't have the bandwidth to look at it on Tuesday, I can look at it on Friday. But at least I've got some type of sampling done. Please do not overexhaust yourself and start collecting things that you cannot look at. Only look at things that you have the bandwidth to look at. And I can tell you, if you have some less senior DBAs, this is an excellent methodology to train them and to go through the process, even with your developers, to go through these queries and look at these highest CPU consumption ones. Next. So now if you look here, I've got the cache information. In there, if I wanted to include in this chart, it could be the statement ID, as Adrian mentioned, so I can focus my attention on the statement ID and pull up that information and actually view the statement. So if I go into this information, I can sort by highest execution, and let's say, let's do a highest execution. Let me look at that query. Let me view the statement. I have that option. Or I can invoke my single query tools and advisors. And once again, no charge. So we provide you with your statistics advisor for a single query. And that is beneficial for you in more than one level. Even if I'm doing a single query with Stats Advisor, you can discover a pattern. If you are not collecting correctly in a single query, I can guarantee you're not collecting correctly across the board. So you can see outside the box. So that's why we're trying to give you this as a technology preview, right? So you can run that. So now that I've looked at that statement, I want to focus my attention. I can and this is why we've done this. So there's a nice little tab here that you'll now notice, this little button here. It allows you to export that data into a CSV file, an Excel spreadsheet. For some reason, we did a survey, and we learned that DBAs spend 50% of their time creating reports. God bless you all. If I had enough time to create all these reports, you know, it would be a better day, right? But so now we've made your life easier. So now you just plop this in a spreadsheet. And the reason why I say that is, unfortunately, inside Data Studio, we can only sort by one column. So when you're in an Excel spreadsheet, I can sort by multiple columns. I can say, let's say, highest CPU time and execution. And which query is that? And can I look at that query? And then that lets you focus your attention even more. So you have that ability to export that into a spreadsheet, share it with your team members, and go from there. After I've done that, I can then put it inside the transformation, and I can actually look at the formatted query. If you look at the formatted query, let's imagine we have a 40-page long query. You don't even know where it starts, let alone to know where it ends. You have no idea what this developer was actually doing. He probably had no idea either. And so when he created this query, you're like, now I need to decide what's going on, right? I need to logically understand what they were intending on doing so I can understand what we're supposed to do. So we easily format the query for you. You can see the tables, table sections, joined, and predicates. You can actually expand and collapse sections. If I highlight a certain part, it highlights the other relevant components of that query that are related. Now, see this little thing here? That means there's skewed data. So within that same 10 seconds that I put in that, invoke my single query tools and advisors, I know that I've got skewed data. Now, if you forget what anything means, we like to explain it again. So here, I've got skewed data. So if you forget what it means, I've got skewed data in this query. Now, this middle column with the $sign that comes with the fee, what I want to tell you is this stuff is all explained inside the Stats Advisor report, too. So don't feel like we've taken anything away from you, right? So inside the Stats Advisor report, if I ran it through my Statistics Advisor, I would know that I've got missing statistics. So right off the top, you already know within that 5 or 10 seconds, I know I've got skewed data, I know I've got missing statistics, and I can go to the next step. In the new version of Data Studio, you now have the ability to save this pretty formatting. So once you've saved it, now you've looked at it, now you can save it. The reason you want to save it is if somebody made an error, you want to show them what they've done, right? You want to explain it to them. You could email that formatting to your developer. You can talk about it amongst your team members. You can work, and now you don't need to reinvent the wheel again. Whoops, sorry about that. So most of you that have Data Studio probably don't know what this transformation tab means. So the first tab was the original of the formatted query, right? I've got the skewed data. I know all that information. If I click the Transform tab, I now know what DB2 has done under the covers with my query to process it. Because you not only need to understand what the person was intending on doing with your query, you need to understand what DB2 or the optimizer has done to process your query. So now I know that DB2 has created a virtual table to process the correlated subquery. So now I'm even smarter than I was before. So now I can go into the next step after I've done that. Now, here's your access plan visualization. Sometimes take a rocket scientist to know how to read this access plan graph, but we spent a lot of time trying to teach people how to read the graph. The graph is read left to right, bottom up. Completely illogical if you ask me. And as I've said before, I like to call people in my office, flip the direction of the graph and start asking questions, because then they start getting all crazy because I've got the graph in a different direction. But for me, even if I don't know how to read the graph, I don't have the bandwidth to go through my whole access plan visualization, right? I focus my attention on one node. I get that node and I right-click. I get the CPU time, the costing information, and all that associated to it there. Now, Adrian gave you some numbers. As we know, costing, it depends. It's never black and white. But let's say I write the query the first time. I have this costing information. I ran it through the Stats Advisor, or I rewrite my query. Once I rewrite my query, I run the explain again, and I compare the exact same node costing information. Even if it changes just a little bit, but it's been executed 1,000,000 times, you're just the hero. So think about it in that concept. Even if you're trying to, your developers are not going to know how to read this graph, right? If you're trying to train them on how to understand what you do or empathize with your job or get them to be better in the way they think, this is a good first step. Teach them how to look at the nodes. Teach them how to look at the costing. Teach them how to look at the execution count information. The other thing I want you to notice, if you look at the line item table on the bottom, you see these little nodes associated, these little icons associated to it. That means there's statistics recommendations found. Focus your attention there and try to figure it out. Statistics recommendations, by that, what I mean by that is you're going to get information on missing statistics, out-of-date statistics, and conflicting statistics. Now, in your environment, what does conflicting mean? It means it was taken at 2 different time intervals. When can that happen? When can your table and your index not match? I do a reorg. Oh, go ahead. Feel free. I do a reorg. It's the same. I do the same thing. I talk to myself. It's when I answer my own questions. That's what happens when you spend a lot of time with self. So, and many of you DBAs, I've heard you guys talk to yourself. So this is usual, right? So I do a reorg. It updates my index, but doesn't update my table information. And that's what I say about discovering a pattern. Even if you have that single query, right? I have that single query. It shows me I've got conflicts in that single query. I'm collecting incorrectly. right? I am not collecting my table information when I need to. It doesn't have that proper information. So maybe I can talk to the other DBAs and say, how are we collecting the statistics? Because unfortunately, as we used to call it, back into times of, as Adrian said, I age myself to version 5. So back in the time of version 5, we used to have this pinata approach, right? Hey, I'll try this. Maybe this will work in my Candio fallout. I'll try this. And then my Candio fallout, version 10, version 11, and whatever the next release is going to be called, you can beat your pinata all you want trying to use these tricks of the trade. It's not going to work. You guys are going to have to put these distributions in. You guys are going to have to put these call groups in. It's going to take rocket science, right? But now we're giving you stuff for free. Use it. As long as you understand the concepts that Adrian mentioned, as Terry mentions, as everybody mentions, we've made your life easier and given you what you need. So, a little appendix for you. How many people have Data Studio installed? I love this room. I'll give you guys hugs later, and we'll bond. So, what I've done is to make your life easier, I've included all the information. You see on the website we have 4.1.1, and I know you guys hate us giving you guys multiple releases and doing these dot releases, but I'm going to give you a trick of the trade. How to know what release you need to be on. So if I'm using version 11, I look and see what's new in Data Studio. And if it says that it's got features that work with version 11, I go to that release. So if you're not going to version 11 in this year, which you all should be, but if you're not, then don't go to 4.1.1. If you're not using IDAA, you do not need to go to 4.1.1. You could stay at 4.1. But I can tell you, you can avoid known issues and things like that if you go to the latest release. So what I've done is I've given you inside here some hints and tips. Hints and tips that you probably don't already know, even if you're installed. So there is some things like your shared SQLID, as I mentioned, we're only going to have one set of explain tables. If we have that one set of explain tables and you want to change your default SQLID and schema, you'll go to the database connection, change your default SQLID and schema here. Next thing I want to show you. We all love to have a tool that just goes and runs and just does everything. But you guys have to do customizations. Everything in the environment, and what IBM says is not always right. Okay? We are ultra conservative at times. So you're going to go into the preferences. You're going to go preferences, data management, and change some preference settings. If you do not have, let's say, we do no longer require you to have explain authority. You don't need to have sysadmin authority to run explain anymore. So if you do not have sysadmin, you just check this little button here, and you use the store procedure so you don't have explain authority anymore. So that's all in the preferences tab here. Next thing I want you to check. In your statistics advisor, by default with Data Studio, we say stale data is 3 days old. Anybody want to laugh at that? I think you should, personally, right? Because we know our test environment could be 7, 10, 30 days old, right? So go ahead and customize here and say number of days old, 3, 5, 7, whatever you wish. And then the recommendations won't pop out everything under the sun, right? And then you can customize it. My only advice to you is if you change preferences in yours to 3, if she changes it to 7 and you change it to 10, you guys are all going to get different advice. So wherever you have forward, put your preferences, save your preferences, export them to the shared drive, and make sure that everybody in the company uses the exact same preferences data. Same with the DB2 connections. Never reinvent the wheel. Share everything with your teammates. Then you guys don't need to add every single database connection. So that is the preferences information that you all have here. And it gives you all the information that you guys can actually go through and the silent install options. If you go through any of this, yes, ma'am. Yeah, it's actually in the previous one. Yeah, so you just have, thank you, ma'am. So stay connected is one of those things, as well as there is another thing in there that says, notify me in 15 minutes if I get an error or an add-in or when my explain changes. please change that to 1 minute. If anybody else is impatient like me, I do not have 15 minutes to wait around to let me know if I've got an admin going on. So go in there and customize it and change it to 1 minute or 2 minute, however long your patience level is. How's that? Yes, ma'am. Yes. So if you go here, you can either do the silent install that we've given you the option, or right here, this little button right here allows you to export, and it gives you your options of exporting your connections. Because if you get a new laptop, it won't recognize your connections, and you'll need to export and import. So always save them before you get a new laptop. But my email address is on the front of this. Everybody knows how to find me. I am the only Saghi in all of IBM. So if you guys ever need anything, I am more than happy to help you guys. Thank you very much.